Okay, so we got this Christie Pulitzer plane, 360 miles against the headwind in 3 hours. The flight would take 2 hours and 15 minutes with a tailwind, the same speed. Find the headwind and speed of the plane in still air. So I've kind of laid it out here, 360 miles with a headwind against the wind. So he's got to go, that takes 3 hours. It only takes 2 hours and 15 minutes for the same trip coming back with a tailwind. It takes the same amount of time, same speed. Find the headwind and speed of the plane. So I found that if you set this up, rate times time equals distance, make this little chart, this really helps organize your mind. And we have with the wind, and we have against the wind. I'm going to switch, it doesn't matter the variables, but I'm going to switch these around. Let's go Y here and go X here. You'll see why in a second. So with the wind, how fast is the aircraft going? It's the speed in still air plus the wind, right? That's the tailwind. That's the 2 hours and 15 minutes. 2 hours and 15 minutes is 2 1/4, right? Actually, I'm going to use 2.25. That might be even better. Hours. You can't have minutes. It's got to be all hours. I think we'll change it to 2.25, okay? Against the wind, it's the speed in still air minus the wind. It slows you down, doesn't it? That took 3 hours, and they both went the same distance. So now it's just a matter of applying the formula. Rate times time equals distance. Rate times time equals distance. So 2.25 times x plus y equals 360. 3 times x minus y equals 360. And we just got to solve. So both these equations, like the second one, I'm going to divide by 3. Look at that. That cleans it up really nice. And the second one, I'm going to divide it by 2.25. It cleans that one up really nice. I take 360 divided by 2.25, it's 160. Now we just add these together. You're going to 2x, the y's cancel. That gives you 280, x equals 140, and that's correct. I checked it out. So if x is 140, plug it back here, then y has to be 20, right? 140 plus 20 equals 160. So there you go.